And today, my talk, we are going to talk about the large-scale assessments of soil health in Brazil, and I will present to you the soil bioanalysis technology. But first, a couple of words about EMBRAPA. EMBRAPA is the Brazilian Corporation for Agricultural Research. EMBRAPA was created in 1973. We are celebrating our 50th anniversary this year. We have 46 units of EMBRAPA all over Brazil. And I am from EMBRAPA Cerrados, which is located in Brasilia, in the Cerrados region. The Cerrado region is the most important agricultural region in Brazil, with more than 200 million hectares. Well, back to soil health. We all know that soil is alive, soil works like a superorganism, and this superorganism can get sick. And today, we have a large amount of data in Brazil showing us that among many, many advantages, an important one, advantage is that healthy soils are more productive than unhealthy, diseased soils. This data come from the literature and shows us that regarding soybeans, when soybeans produced in healthy soils, it produce on average 686 kilograms more per hectare as compared to when soybean is grown in unhealthy, diseased soils. But the whole point is, how to know whether your soil is healthy, how to know whether your soil is sick, how to do the diagnosis. Well, for that, I am going to talk about 20 years of research in 20 minutes, so hopefully I will succeed on that purpose. Well, since July 2020, we are living a new moment, a new and a very special moment in Brazil. For the first time ever, we have the presence of two biological indicators as part of our routine soil analysis. These biological indicators are two soil enzymes, one from the carbon cycle called beta-glucosidase, and the other from the sulfur cycle called arylsulfatase. And the inclusion of these two soil enzymes as part of our routine soil analysis is called soil bioanalysis, in short, soil bio. And I'm going to show you that it's a very sensitive, calibrated, and simple tool for soil health assessment. I like to say that soil bioanalysis, soil bio, is like the soil's blood test. In the same way that you perform your soil blood test to find out how is your soil health, your health condition, with the bioanalysis, it allows us to anticipate asymptomatic soil health problems before they reflect in terms of losses of grain yield in our crops. And enzymes, they work as they were ecosensor radars. They are more sensitive than soil organic matter to detect changes that are occurring in our soils in terms of losing health or gaining health. So they can work as messengers of good news and also as messengers of bad news. And why arylsulfatase and beta-glucosidase? Why these two soil enzymes? Well, as I told you, the choice of beta-glucosidase and arylsulfatase was the result of more than 20 years of research in our Cerrado soils. And these two enzymes, they are more sensitive than soil organic matter to detect changes that are occurring in our soils as a function of the different management practices. They are related to soil functioning, in this case, nutrient cycling. They are correlated with other microbial indicators of soil health, such as soil microbial biomass, soil respiration, soil microbial diversity. They are precise, coherent, simple, and their determination is very inexpensive, and the analytical procedures for performing enzyme assays are very simple. And also, they can be performed directly in air-dried soil samples, which really makes easier their adoption by commercial laboratories. Another very important advantage of working with beta-glucosidase and arylsulfatase is that both are highly correlated with grain yield, which is very important because it's the economical aspect, and also they are highly correlated with soil organic matter, which is the most important indicator of soil health that we have. In addition, I like to say that these soil enzymes, they have very powerful connections in the soil, They are very good connections with soil physics. We know that soils with high enzyme activities, they store more water. They have lower populations of phytonematodes. They have a better nutrient use efficiency. They have better potential for bioremediation. And they even have better food quality. So soils with high enzyme active levels, the quality of the grain yield produced in these areas is completely different from the quality of the grain yield that's produced in sick, unhealthy soils. And we have data for all these, but of course I'm not able to show you because we are running out of time. But one important thing about the soil bioanalysis protocol is that it's all standardized. So we have since how to perform the soil sampling until how to produce the soil bio report is all standardized. And we are not talking about harmonization, we are talking about standardization. So in terms of how to collect, how to perform the soil sampling, the procedure is similar to the procedure used for soil chemistry, but the only thing that changes, and that change is very important, is that for soil bio, the diagnostic soil layer must be the 0 to 10 centimeters depth. Okay, so that's the most important point. Well, in terms of when to perform this evaluation, it must be done after harvesting your cash crop. So it's not during the flowering stage or anything like that, just after harvesting your cash crop. In Brazil, usually we have a soybean maize double crop, so it's after the maize crop, just at the very end of the rain season, beginning of the dry season. And if you are doing a monitoring program, it's very important to perform soil sampling at the same time every year. In terms of soil handling procedures, the soil bioanalysis must be performed in air-dried soil samples in the same way that we do for soil chemical analysis, and the soil samples must be sieved in a 2 millimeter sieve. Well, the most important contribution of our research to develop this technology was exactly how to interpret the individual values of these soil enzymes. For instance, if you do your blood test and then you had your glucose numbers, 80. Okay, 80. But what does that number mean? Is it good? Is it moderate? Is it high? Is it low? So in the same way for soil enzymes, it's no use if you only determine the numbers. You need to know what that numbers mean. So in order to that, we develop a strategy to define reference levels for these soil enzymes. In order to do that, we work in long-term field experiments. In the same way that people define the reference levels for the nutrients, for the soil nutrients, phosphorus, calcium, potassium, etc., we made response curves for soil enzymes. So in these long-term field experiments, we have side-by-side plots with healthy soils and unhealthy soils, and we were able to make these response curves. So the enzyme level to reach, let's say, 8% of maximum grain yield was considered adequate. The enzyme level to produce 40% of maximum grain yield was considered low. The same way that people do the calibration for phosphorus, potassium, calcium. And that's the way that we developed our first interpretation tables for soil enzymes. But now we don't have just interpretation tables. Now we have interpretative algorithms to estimate enzyme reference levels as a function of the clay content of our soils. For instance, the reference levels for soil enzymes in a sandy soil is completely different from the enzyme reference levels in a clay soil, okay? Well, so calibration. Calibration is the magic word for the development of this technology. You need to know to find out what those numbers really mean, so calibration, very important. At the current stage, soil bio is calibrated for annual crops in the Cerrados regions and also in the southern states of Brazil. And by the end of the next year, we are going to develop soil bio for sugarcane, coffee, pastures, and eucalyptus. Well, but soil bio goes beyond the determination of these two soil enzymes. Well, in the soil bio, we also have the calculation of soil quality indexes, and we also calculate scores for very important soil functions related to the plant nutrition, which are nutrient cycling, nutrient storage, and nutrient supply. How we did that? Well, basically, we got all those parameters that we already had in our soil chemical analysis: organic matter, cation exchange capacity, the acidity components, base supply, phosphorus supply. We included now our two soil enzymes, beta-glucosidase and arylsulfatase, and all these parameters are integrated in soil functions. So, for instance, soil enzymes are related with the nutrient cycling function. Organic matter and cation exchange capacity are associated with nutrient storage, and acidity components, base supplies, etc., are related to the nutrient supply functions. All these soil functions are aggregated in soil quality index. Nutrient cycle is equivalent to the biological soil quality index. The average of nutrient storage and nutrient supply constitute the chemical soil quality index, and the integration of both biological and chemical give us the Fertibio soil quality index. Why I'm explaining this to you? Because this is the heart of the technology. And based with the scores that we have for these numbers, is that we can say if our soil is healthy, unhealthy, getting sick, or recovering from a degradation process. All these scores, they range from 0 to 1. The closer to 1, the better. And they were all, again, calibrated in long-term field experiments as a function of grain yield and soil organic matter. So we have numbers calibrated. So for instance, if you have a high punctuation, high score for the soil quality, for the soil biological index, that means that your soil environment has a very good yield potential, okay? Calibration. And in order to make it easier for farmers to understand the soil bio report, we use a 5-color scheme based on a traffic light model. You know, the closer to the green, the better. The closer to the red, the worse. Like simple like this. The thing is that now in Brazil, we are making the transition from this traditional soil analysis report based completely in the mineralistic concept of phosphorus, potassium, calcium, magnesium, and now we are moving towards, and so we are making the transition for this new soil report, which is the soil bio report. Here it's how it looks like. So basically, we have for each place in your farm, which is in the lines, in the columns we have the enzyme activity levels, the soil organic matter, both interpreted using that 5-color schemes. And we also have the calculation of the 3 soil quality indexes, the fertibio, the biological, and the chemical. And we also have the punctuation for those 3 soil functions: nutrient cycling, nutrient storage, and nutrient supply. So this is a new way, a new view of your soil that goes beyond excess or lack of nutrients. You know, now you can see the ability of your soil to function to supply, store, and cycle nutrients. That's it. Well, how it works? Well, EMBRAPA doesn't perform any kind of soil bioanalysis. It is all performed by commercial soil labs. And we are creating this network, this innovation network with commercial soil labs. They are our partners. It's a private-public partnership. And these commercial labs, they are capacitated by us. Before the pandemics, we did this capacitation in person, and during the pandemics, it was made online. And also, in order to make part of this network, they also have to pass, like in several interlaboratorial tests, so that we guarantee the excellence and the high quality of the analysis that will reach our farmers, okay? Now, well, during the first 3 years since we released the technology, we had 7 commercial soil labs working with us, and now finally our bureaucracy has allowed us to expand the number of commercial laboratories performing soil bioanalysis. So at the beginning of this month, finally, we have now 33 commercial soil labs in Brazil performing soil bioanalysis. In most part of them are also members of the GLOSOLAN, the Global Soil Laboratory Network by FAO. Well, so how does it work? All these commercial laboratories, they are connected with EMBRAPA by a web platform called Soil Quality Interpretation Module. So the commercial lab makes the enzymes determination, and then he uploads these numbers in our web platform, and this web platform automatically interprets the enzyme results and also calculate those soil quality index and the punctuation of those soil function scores. So it's automatic. Oops. And at the end, we can tell to our farmers exactly whether the soil is healthy, is getting sick, is sick, or is recovering. I'll tell you how it works. Remember that I really want to make clear how the heart of the soil bioanalysis technology, the conceptual model. Okay, so based on the scores of those 2 soil functions, nutrient cycling, which is related with the enzymes, and nutrient storage, which is related to soil organic matter, by combining these scores, we can conclude how is the soil health condition. For instance, in a healthy soil, we have high punctuation, high scores for both functions, soil enzymes, nutrient cycling, and nutrient storage. If your soil starts to get sick, soil enzymes are more sensitive, so they decrease faster. So then you have low scores for soil enzymes, and high scores for soil organic matter. If this process of getting sick keeps going, then your soil is going to be unhealthy, it's going to be diseased. So you're going to have low scores for soil enzymes, low scores also for soil organic matter. And in the other end, if your soil is regenerating, you have a degraded soil, and you start to regenerate that soil enzymes, they are good messages of good news, so they increase faster. So then you have high punctuation for enzymes and low punctuation for the nutrient storage function. So 4 different patterns found in nature. They are there. It's just a matter of, calibrated technology and to find out what is low and what's high. Well, I'm going to give you from now on some examples of real-life farms, commercial farms, and all this data came from commercial laboratories of the EMBRAPA Soil Bio Network. Well, the first kind of the soil bio report, type 1, is healthy soil. So here we have a farm. It's a farm in Mato Grosso, 1,500 hectares. So you can see just by the colors that the farm is in a very good health condition, right? In this case, it's chemically and biologically excellent. So you don't need to see the numbers, Here we have a farm with 1,500 hectares. Look how fast you got you can see how's the soil health condition. And the secret of this farm, Carlos and Amanda, is integrated crop livestock. It's the best way to keep your soil healthy. Perform integration with crop and livestock. The second type of the soil bio report is of the soil getting sick. In this case, we have high punctuation for soil organic matter and low punctuation for soil enzymes. It's like the farmer has a bomb in its soil, and if he doesn't take care, this bomb will explode. So here, we can see low punctuation, high punctuation in the soil organic matter function, nutrient storage, and low punctuation, low scores in the nutrient cycling. So the soil is degraded from the biological point of view. The third type of the soil bio report is when the soil is sick. So in this case, the bomb has exploded because you not only lost your biological component, but you also lost soil organic matter, which is the most important soil health indicator that we have, right? So here's another example of type 3. The bomb has exploded, low punctuation in both functions, nutrient storage and nutrient cycling. And it's interesting, I want to call your attention because please look at the punctuation of the nutrient supply function in this type 3 soil bio report, and also in type 2 soil bio report. The nutrient supply function is an excellent condition. So what does that mean? That means that many times you have your soil chemically in an excellent condition, but however, the soil is sick. And in situations like that, where you have chemically corrected soils, many times the farmer wants to recover that soil, and what he does before soil bioanalysis, he used to put more fertilizers, more pesticides, which is the right medicine, but for the wrong disease. It's not with pesticides and fertilizers that will improve the soil health condition. In order to improve the soil health condition, you need to change your management practices, okay? And the type 4 kind of soil bio report is the bio report of the hope. In this case, it's a degraded soil. The punctuation of the soil function associated with soil organic matter is very low, but the punctuation of the soil enzymes is high, showing that the farmer is adopting practices that are regenerating its soils. See how it works here in the practice. A railroad farm, again, a commercial farm, low punctuation in the nutrient storage and high scores in the nutrient cycle. So that's how it works. These 4 farms, we gathered all the numbers regarding the average soybean yield during the past 4 years in these 4 farms, and look how interesting it is. The healthy soils, in the soils recovering, the yield levels were around 500 kilograms greater than the yield levels obtained in the soils getting sick, which show again that, remember those first numbers that I showed you in the presentation? Again, health soils are more productive, and now we have data at the farm level. Well, how it works in the field. Another example from a big farm in Brazil. This is a Payaguás farm, a farm with 40,000 hectares in Mato Grosso, 40,000 hectares. Each square in this picture has about 300 hectares. Well, look at the map of the supply function. That supply function is the that function associated with the routine chemical analysis, phosphorus, potassium, calcium, magnesium. The whole farm is in excellent condition. But then, when we produce the soil health map based on the punctuation of the nutrient cycling, the nutrient storage, we can see that we have a new view of this farm. And although chemically is perfect, we see a lot of places where the soil is healthy, or is diseased, or is getting sick. Okay, so that's why I say that's a new view that we have in terms of our soil analysis. And as Maria just said, for biological nitrogen fixation, soil bio also works for small farms as well. So here we have many examples of small farms, small farmers in Brazil using soil bio. And in that case over there, see, we have a low scores even in the supply function, right? Which is very common for small farms because they don't have access to fertilizers, to acidity correctors, and all that. Well, and based on all these 3 years after the release of the technology, now we have a data bank with 28,000 soil samples. I'm sure it's the biggest data bank in terms of soil enzymes that we have in the whole world. And here in this map, we show the distribution of the number of soil biosamples in the different Brazilian municipalities. In Brazil, we have around 5,000 municipalities, and we have soil bios is calibrated for around 1,000 of these municipalities. And here we can see the number of samples in each municipality of Brazil. And based on these numbers, and in our data bank, now we have, ladies and gentlemen, the first version of the soil health map of Brazil. Now we can see how Brazilian soils are doing by each municipality. So, again, following that 5-color scheme, the closer to the red, the worse, the closer to the green, the better. So nowadays, based on these 28,000 soil samples that we have in our data bank, 67% of our soils in a healthy and recovering condition, 24% are getting sick, and only 2.5% are sick. Isn't that amazing? And here is also the kind of data that is emerging from this data bank. Here we have, for the Paraná state, which is one of the big producers, agricultural states in Brazil, here we have a regression where we have in the y-axis soybean yield from 5 years, average 5 years, and in the x-axis we have the percent of soil getting sick or sick. And what we observe a negative relation. What means? Less soybean production in those areas with high amount of soils sick and getting sick. So, for instance, in the case of the Paraná state, the R2 of this regression is around 7.6, which is really good. So, 2 soil enzymes, organic matter, that's what the kind of data that we now have in Brazil. This is Paraná state, but we also have, as I told you, this data also for Mato Grosso, Minas Gerais, and the other states. The whole thing that I want to show is that in terms of spatial scale, we developed this technology in field plots, and now it's working at the farm level, at the states, at municipalities levels, at state, and also countrywide. So here is how it is only, again, based on 2 enzymes and soil organic matter. So calibration is the secret. It's a technology that's simple, practical, and scalable. It works inside and outside the farm gate. And we talk a lot about metrics to evaluate soil health, blah, blah, blah. Here we have a metrics that fall in those 3 principles: measurement, reporting, and verification. All the papers that form the basis of the soil bio approach are published in the best journals of soil science. So it is all published on how we developed this technology, the strategy for the enzymes interpretation, the calculation of the soil quality index, and all that. And coming 2024, I don't know if you are familiar with the soil health series by the Soil Science Society of America. Volume 1 was associated to approach to soil health analysis. Number 2 was based on laboratory methods for soil health analysis. And volume 3, which is going to be out, it's coming next year, is about soil health and sustainable agriculture in Brazil. And several authors, several persons here have chapters in this book. Professor Sidney, for example. And in this book, we are going to show to the world how Brazil is approaching soil health, how soil scientists and how Brazilian farmers, and how is our commitment in terms of having productive soils, productive crops in healthy soils. Okay. And well, to access soil's memory, because in fact we are establishing a biochemical dialogue with our soils using these two soil enzymes. So assessing soil's memories was really a complex problem, but at EMBRAPA we want to make we have to make easier the lives of our farmers. So we have to develop simple solutions. So soil bio is really the simple solution. And I'm gonna end my talk with this quote from our great Leonardo da Vinci. He said, "Simplicity is the ultimate sophistication." So two soil enzymes plus your soil organic matter, you calculate all those scores, and you can say if your soil is healthy, getting sick, or recovering from a degradation process. And the cost, in terms of costs, one complete soil bioanalysis today in Brazil costs $36. Well, this is not a work of one person. We have a lot of people working in this project, a group of wonderful, motivated, and committed researchers, students, field technicians, field workers. Everybody's over there. And thank you so much. Muito obrigada for your attention.